Looking again at the student height data, we know that there's a difference in height between men and women. So instead of just calculating the confidence interval, or we could actually have done this for the mean and standard error. For the whole data set, what you can do is split it by factor. So in this case, split it by gender. So what you want to do is go to Analyze, Descriptive Statistics, and Explore. So you want to put in height. It's gone in here already. But here you want to put in factor, which is gender. So again, you can change the confidence level if you want to from 95%. We'll leave it to that level this time. And now we press OK. So instead of having a single value for all of the different heights, now you've got it split by female, male, and prefer not to say. So in this case, the confidence interval for the female heights goes from 1.625 to 1.64, and the male confidence interval goes from 1.76 meters to 1.80 meters. So these two confidence intervals are very different to one another. This is telling you that it's very unlikely that the mean height of women is the same as the mean height of men. In fact, this is very strong evidence that they're not the same, because at the 95% level they do not overlap at all, and in fact they're not very close to each other in any shape or form. For the prefer not to say, the confidence interval is much wider because the sample size is much smaller. There's only 7 people in that particular data set. So in this case, there's going to be a lot of overlap with the other confidence intervals, and you cannot say that they're definitely different to one another. Similarly, the mean and standard error for women's height is 1.63 and for male is 1.78. The male difference, the male standard error for the mean is about 1 centimetre, and for female it's 4 millimeters. This is saying that the female variation is much smaller because of the size of the data set. There are way few women